To get started, let's draw four parabolas, each facing a different direction. Now, which of these is the correct graph for the equation y equals x squared? And if you'd like to review, click down here instead. Exactly, so here's the graph for y equals x squared. Now with this interactive graph, you can draw different parabolas by dragging these three sliders at the bottom. A is the coefficient of the x squared term, B is the coefficient of the x term, and C is the constant term. So at this point, try making a quadratic graph with a negative y-intercept. Once you've got one, press the Submit button over here. Great! So here's another example of a graph with a negative y-intercept. Now remember, you can always find a graph's y-intercept by setting x equal to 0, because every point on the y-axis has an x-coordinate of 0. So if we set x to 0 in this equation, the x squared term is 0, and the x term is also 0. So the y-intercept is then just negative 2.4. And looking at the graph, sure enough, the y-intercept seems to be negative 2.4. So then what do you think would be the y-intercept for this quadratic? Y equals 2x squared minus 6x plus 7. Excellent. Next, here's the graph for y equals x squared plus 2x. Notice that this graph has a lowest point over here, and then it goes up on either side. Try making a quadratic graph that instead has a highest point and goes down on either side. Perfect. So here's another example of a quadratic graph with a highest point. You might have noticed a pattern. Whenever a, the coefficient of the x squared term, is positive, the graph goes up in either direction and has a lowest point. And when a is negative, the graph goes down in either direction and has a highest point. And when a is exactly 0, like here, well, then the x squared term is 0. You only have an x term and a constant term, so this is a line. Okay, now notice that this quadratic has two x-intercepts, one over here and the other over here. Try making a quadratic graph that has no x-intercepts. Excellent, so here's another graph with no x-intercepts. Next, try making a quadratic graph that has exactly one x-intercept. Nicely done. Here's another graph with exactly one x-intercept when x equals 1. For your final challenge, make the graph for y equals x squared minus 2x minus 2. Which of these values appear to be the x-intercepts for that graph? Well done. So here's the graph for y equals x squared minus 2x minus 2. And sure enough, its x-intercepts are at approximately 2.7 and negative 0.7. In a later lesson, you'll discover a way to calculate a quadratic graph's x-intercepts by just using the three coefficients. To get started, multiply these two binomials, x plus 3 and x plus 4. Be sure to combine all the like terms in your answer, or click down here to review. Right, the first terms multiply to x squared, the outside terms are 4x, the inside terms are 3x, and the last terms are 12. 4x plus 3x equals 7x. So this product equals x squared plus 7x plus 12. Now, as we've said, multiplying polynomials to get a higher degree polynomial is called expansion. But when you go the other way, writing a polynomial as the product of smaller polynomials, that's called factoring. Try out an example. If you were to factor x squared plus 6x plus 5, you would find that it equals x plus 5 times x plus another number. Can you figure out what the missing number over here has to be? Exactly, this number is 1. This way, the last term will be 5 times 1, or 5, and adding the outside term, which is x, to the inside term, which is 5x, you'll get 6x. So yes, x squared plus 6x plus 5 equals x plus 5 times x plus 1. Try another example. Can you factor x squared plus 9x plus 18? So your answer should have two binomials in parentheses that you're multiplying together. This is not an easy computation to do, so if you get stuck, feel free to ask for a hint. Nicely done! X squared plus 9x plus 18 equals x plus 6 times x plus 3. Here's your next challenge. Factor x squared plus 2x minus 35. This time, notice that there's a minus sign in the quadratic, so make sure multiplying the two last terms will give you a negative number. Excellent! So this equals x plus 7 times x minus 5. The last term is 7 times negative 5, or negative 35. And adding the outside term, negative 5x, and the inside term, 7x, you get 2x. Next, try factoring x squared minus 13x plus 42. Again, notice the minus sign over here as well as the plus sign here. Right, that one was tricky. X squared minus 13x plus 42 equals x minus 7 times x minus 6. Multiplying negative 7 and negative 6 gives you positive 42 because the minus signs cancel out. And combining the outside term, negative 6x, with the inside term, negative 7x, you get negative 13x. Next, try factoring this expression, 2x squared plus 7x plus 3. And for this one, keep in mind that the leading coefficient is 2. If you get stuck, click over here and we'll figure this out together. Excellent work! 2x squared plus 7x plus 3 equals 2x plus 1 times x plus 3. Try another example. Factor 3x squared plus x minus 2. And again, notice that the leading coefficient is 3 and that the constant term is negative. Right, so 3x squared plus x minus 2 equals 3x minus 2 times x plus 1. Let's finish this lesson by looking at a factorization like x minus 2 times x minus 5 and asking the following question. For which values of x will this expression be equal to 0? There are two unique answers to this question. Take a minute to think about it and then enter your two answers over here. Exactly. If x equals 2, then this first binomial becomes 2 minus 2, or 0. And 0 times anything always gives you 0. And the same goes for when x equals 5. This binomial will equal 0. Now if you expand x minus 2 times x minus 5, you get x squared minus 7x plus 10. So you actually just figured out when this quadratic is equal to 0. Let's double check that. When x equals 2, x squared is 4, minus 7x is minus 14, and then plus 10. And sure enough, this equals 0. And when x equals 5, x squared is 25, minus 7x is minus 35, and then plus 10. Once again, this equals 0. So if you have a polynomial that's equal to 0, one way to find the solutions is to factor the polynomial. Try another example. Suppose x squared minus 2x minus 8 equals 0. Can you solve this equation for x? So first, try factoring this quadratic, and then set each of the binomials equal to 0 to find your two answers. And if you get stuck, feel free to ask for a hint. Great, so x squared minus 2x minus 8 equals x minus 4 times x plus 2, and this is equal to 0. When x minus 4 equals 0, that means x equals 4. And when x plus 2 equals 0, that means x equals negative 2. Okay, last question. Suppose you're asked to solve the equation 3x squared plus x minus 2 equals 0. Now, you already factored this quadratic. It's 3x minus 2 times x plus 1. So this is equal to 0. So again, try setting each of these binomials equal to 0 to find the two solutions. Precisely, setting 3x minus 2 equal to 0, you found that x equals 2/3, so you got a fractional answer. And setting x plus 1 equal to 0, you found that x equals negative 1. Let's quickly double check these answers. When x equals 2/3, 3x squared works out to be 4/3. X is 2/3, and then we're subtracting 2. Sure enough, this gives you 0. And when x equals -1, 3x squared is 3, x is -1, and we're again subtracting 2. And this also gives you 0. Factoring quadratics can be very tricky work, but with practice, you'll get the hang of it.